Hello everyone. So a man and a lady, they come with this ps4 for no power, and the lady, she asked me if using USBs here to charge a device like a phone will make the ps4 go no power. But I understand from the lady question, the guy was visiting family, or he was charging his phone from the ps4. As he said, he just did it one time. Next day the ps4 goes for no power, and the lady trying to blame him for this problem, to make him pay for the repair or pay for the replacement console. Yeah, I explained the lady this ps4, which has a common issue with power supplies, and likely is not cause charging the device from USB will make the console go to no power. Let's check this one and see what's going on. So here, plug it to the power. No power. So we're going to take it apart and we check it in. So here is something that I did see here. You can see some cockroaches mess over there. This bug is number one killing electronics. Like their mess is a conductive to the electricity, and they make jumper corrosions, shorting the components, and I think that's what causing the ps4 to go for no power. Yeah, you can see it's here. Alright, this is the power supply. You see this? This is look like a burned component. It's the burning mark. So must be a burned somewhere. Okay. So this one, it's right here. And look like the guy who caused the problem still sitting over there. See that? The cockroaches still sitting in the same spot. So there is a burned trace or some shirt over there. Yeah, that bug is very conductive. Yeah, it works as a wire. That's why even the board is burned. You see, even the board. Yeah, I don't think this is a trace. From here to here, I don't think there is a trace, because this trace here is going to the diode, this is a MOSFET and MOSFET. So this trace is going to the MOSFET. This trace here yeah, but let's check it to be sure. So this trace is go to the source of the MOSFET. This is the gate, and this is the drain, is going to the transformer. So this gate should be connected to this IC here. This is the switching IC. The one is sending the wave to the MOSFET to go on off. In this transformer there is two coils. There is one here and there is another one here. This coil here, I think this is for the standby voltage, because this is the standby voltage and should be this one for the 12 volt, this transformer here. So this one is for the standby voltage. This coil here should be for the VCC that's powering the IC. Yep. So there is a capacitor here. This is a VCC capacitor. Yeah, should be. This is not a trace. That's just a burnet in the board. So already clean that carbon. Is a conductive too, so it's allowed the electricity to flow. It's gonna need, so that's why I clean it. So let's check. Before we check anything, let's plug it in and see what it's gonna do. Let's plug it to the power. So we're gonna check the voltage and the B capacitors here. We have 160. Because we have 160 volt here, it's mean all the component from here to here, they works fine. Fuse, rectifier bridge, variostore, all of them, they should be good. So let's check the output. We have standby volt here and this pin. 5 volt standby. So this pin, this here is good. You can test it from here. Yeah, there is no voltage. There is no standby voltage. The ground of the primary side is here, and the B capacitor, and the negative side of the capacitor. I can see the negative and the positive, so let's put it here. And we're going to check if there is a power going to the MOSFET. Okay, or we need to put it in the, because the MOSFET is connected to the ground. Yep, we have 160 volt over there. Should be this one 160 as well. So there is 160 going to the transformer, as you see over there. And this should be going here as well. Okay, we don't have, yeah, here is, no, should be from here. The negative. So the positive should be go to the transformer. And I don't see it. So the positive go here, it's go here, to here. There is a jumper from here to here, to here, to here, and it's go to here. So from here to here we have 160. Should be here 160, but we have just, we don't have 160 volt here. Here you can see these jumpers. That's what is carrying the 160 volt to the transformer, because the positive of the B capacitor is going to connect direct to the transformer. The negative side of the capacitor, the ground, it will go to the MOSFET, and the MOSFET is going to carry it for the transformer. So from the positive side to here, we don't have, no connection. To here there is a connection, to here no connection. So this is a low ohm and fuse resistor. So must be this resistor is open, because it's a brown, blue and silver. So must be like under 1 ohm, 0 point something. So this burner trace is here. Let's check it. Or burner mark here. We have a low ohm 2 resistors here. That's a 2 ohm resistor. These 2 ohm resistors here is kind of hard to check that diode because it's connected on parallel with that resistors. So we need to remove that diode and test it. Because we have these 2 resistors are good. So something else I want to check is so there is 160. This is the switch in IC. There is 11 volt here. 11 volt is coming to the VCC is so there is 11 volt here. This 11 volt it must be like a voltage start. When the voltage starts, the switch in IC work at the first, it's going to send the wave to the MOSFET. The MOSFET is going to start carrying for the transformer. Then the transformer is going to start giving these voltages here to the IC. And the IC is not going to use the voltage start anymore. It's going to be working with this voltage from here that's coming from this capacitor here and here. So of course there is no voltage here, there is no voltage on the transformer, and we have no voltage the VCC, and the IC is not going to be cutting. That's what it is. So let's check. Yeah, look like this MOSFET is good. This diode good. This diode is good. This diode is good. It's the ground of the IC. So this is the ground. Alright, yeah, before I do anything, I'm gonna need to check this diode here, and we'll test it. Alright, this diode is shorted, definitely. Yeah. Yeah, it's a low ohm and these give reading both sides. So this diode is bad. So I have another board, kind of similar to this one, 4 part. Already removed this low ohm resistor, his burner too. Yep, it tested open. But we do have the diode. So no reading this way. If we flip, we got the reading. So this diode is good. It's not like the other one. Yes. So that's the bad diode. And we have to check this low ohm resistor. Yep, it's open. You can find these low ohm resistors in any power supply close to the MOSFET. That's the one is connection between the ground and the source of the MOSFET. So if you go here to the ground, you find this resistor here, and that's connected to this MOSFET here. Yep, it's connected. So I'm going to check this low ohm resistor and so let's check the connection between to here, then to here, and all the way to the transformer. So we have a good connection now. Of course, if we test here, it's going to test as a wire because we have these two low ohm resistors, but we still have this diode for safety. This is, I think, is for a safety diode, and this is a Zener diode. It's a ZD, so this one is a Zener diode. So let's test it with the power. Let me unplug it from the source, and I'm gonna plug this one first. And let's put this one in case if anything burn it or explode. Nope. So already plug it to the power, and let's test the 5 volt standby. Let's put this one on the ground, and we have 5 volt. That's great. There is a 5 volt standby over there. So in this capacitor here, we have 15 volt, and that 15 volt is came from the transformer. And from here, from the ground to this one, we have, you remember at the first it was 11 volt, that's the voltage start. Now we have 15 volt in that pan. This power supply now it's fixed. Let's test it in the ps4. All right, we have the light. Fan is on. Still no video signal. Yeah, something detected. And it works. It works. This is a game CD. Yeah, the console works. Yeah, another thing I did see in this specific power supply, if you have all the voltages, if you have the 10 volt and the VCC here, and this diode is good, all the components, you test the diodes here are good, and you don't have the 5 volt, you may need to change this IC. It's a common problem, this IC go bad. So that's all for this video. Thank you for watching, and see you again.